my name is Pavel Koros, and I'm going to present you some of the work that we carried out during multimedia algorithms development carried out under task 5.2 of the INDEX project. The topic of this presentation will be content access protection with digital watermarking. The main idea of this technique is that it allows censorship of sensitive image content, for instance, human faces, car license plates, etc. And the key point is that the original appearance of the image can be reconstructed. So we select particular regions of an image for protection, then it becomes blurry in the image itself, and authorized recipients are able to see the original appearance of the protected fragments. So the details that are necessary for proper reconstruction are encrypted in the image itself. And as I said before, only authorized recipients can see the original image. The distribution model looks more or less like this. Let's assume that we have three parties in our system. The first one is the content author. He's marked as a blue user here, and there are two classes of recipients, unauthorized ones and authorized ones. The content author, he has its images or other multimedia content that he wishes to distribute securely, and he also has a private key, a key that is shared between the content author and authorized recipient, and the key is used to protect the selected part of the image. And in this example, this is the face of the model in the picture, and after this protection the image can be distributed, for instance, to the internet, and the users can download the image, as we can see here, but only the authorized recipient is going to see the original content of the image. I'm going to show you right now the demo of a prototype simple application that demonstrates this technique. Okay, now it's time for a short demo. We have a couple of pictures prepared. These are pictures commonly used in image processing research, so you can use it just for reference. And we have also a couple of other images taken with our HDTV surveillance camera located in our university. Okay, so let's start with the Lena image here. In the upper left picture you can see the original input image. We can then specify the region that is supposed to be protected, like this. And now let's just click protect. And as we can see, the selected region has been blurred right here. And this image that you can see in the bottom left is the one that is supposed to be stored on the hard drive. The information needed to recover original content of this region is embedded in the remaining part of the image. That means somewhere here. And for authorized recipients, the original appearance of the image will be reconstructed, and the final effect of this reconstruction is presented in the bottom right picture. So as you can see, the original face here is quite well reconstructed, and it resembles the original very good. There are a couple of parameters that can be used to control the behavior of this technique. The first one is the protection strength, which basically just controls the amount of blurring that happens here in the region specified. So if we decrease it a little, we can see that the blur is less intense. Okay, but let's stick with the best value here. And the second parameter that we can control is the quantization strength. This is basically the amount of distortion in the image that we can allow, which basically covers the robustness against image processing attacks, like for instance lossy compression. And if we increase this quantization strength here, we can see that the image here becomes more noisy. Okay, let's go back with this value to the original one. And the third parameter, the last one, is the quality, the desired quality of the reconstructed image. And right now, as you can see, the reconstructed part here is quite blurry. And if we increase the quality, we can see that more details, okay, more details appeared here. So we can increase it even more, and we can see that the overall image quality is going to improve. The question might be, what is the optimum value of this quality setting? We can see how it works by using the quality assessment feature here. And let me just click it and observe how thus the images in the bottom part change. Okay, and as we can see here at the beginning, when the quality, the desired quality, is supposed to be very low, the amount of distortion introduced to the remaining part of the image is relatively low, so the quality is going to improve with the quality setting here. And then after a couple of quality values, the improvement is not as big as the additional distortion, so the overall quality begins to decrease. This is an interesting optimization problem, and it's not going to be discussed in more detail here. It was just to show you that there are some optimal values of the parameters here that can be used to increase the performance of the presented technique. The second picture I'm going to show you is this pair of people, and I'm going to show you that our technique can work with arbitrary number of specified regions. Right now I'm going to just select the faces of the people in here in the picture, and we're going to lower the protection strength because these regions are smaller, and let's see what happens right now. Okay, so right now, as you can see, the faces of these people are protected properly. They cannot be seen, and they can be efficiently reconstructed like this. And I'm going to show you that our technique also works on real images. I mean, really taken by a HDTV surveillance camera. So let's just specify this face here. Let's increase this, and let's try. Okay, we see that we have the face blurred here, the face reconstructed here, so it works as desired. And it also works, of course, outdoors. We can think of a scenario of a surveillance cam over a street, and let's select the region to hide this car here. And let's proceed. And as you can see, the car is not visible here, the car is visible here, and we can use it for different purposes, for instance to hide license plate numbers when desired. So thank you for your attention and enjoy.